Assalamualaikum. This is the class where we are going to do the past papers of transformation functions. Just to revise all the concepts which we have done so far. First of all, in the topic of transformations of functions, we have done translation. Okay, so the first thing which we have done here is translation. In case of translation, the graph of f of x, if it is translated horizontally, it's going to be f of, for instance, a units onto the right, it will be x minus a. Okay, and if it is moved a units onto the left, it will be f of x plus a. Okay, if it is translated vertically by a unit, it is going to be f of x plus a if it has gone upwards and if a is positive, and if a is negative, it will be f of x minus a. Okay, I can give you 4 examples on this. This is going to be f of if the point has been translated horizontally by 3 units, it's going to be f of x minus 3. If it is horizontally shifted onto the left by 3 units, it will be, or 2 units, it will be f of x plus 2. If it has gone up by 2 units, it will be f of x plus 2, and if it has gone down by 4 units, it is going to be f of x minus 4. Okay. If at the same time it is going horizontally plus vertically, it will be f of x minus a plus b. Okay. Let us take an example. If it has gone 3 units onto the right and 5 units down, the graph is going to be, the resulting equation is going to be f of x minus 3 negative 5. Okay. This was translation. Now, if we move on to reflection, in this case we have one is reflection in the x axis. So, if f of x is reflected in the x axis, it is going to be, the resulting equation will be negative f of x, and the second thing is reflection in the y axis. If f of x is reflected in the y axis, the resulting equation will be f of negative x. Okay, the third thing is stretches. The first thing here is going to be stretch parallel to the y axis. It is also called a vertical stretch with x axis invariant. In this case, the resulting equation is going to be a times f of x. Okay. So, if it is a stretch of 2 units, it is going to be 2 f of x. Okay. And the second thing is stretch parallel to the x axis. In this case, if f of x is the equation, you can also call it as stretch, horizontal stretch with y axis invariant. In this case, y axis is the invariant line, any point which lies on the y axis will remain as it is. So, it will be written as f of 1 upon, or I can just simply write a x here. Okay. In this case, 2 is the scale factor. In case of the vertical stretch, 2 is the scale factor. Okay. So, here scale factor is 2, and in this case scale factor will be 1 upon a, whatever is written inside the bracket. Okay, you have to reciprocate it, and that becomes the stretch factor. Okay, we've done all of this in the previous videos. If you want more details on these, then you can go through the previous videos, starting with the past paper questions. Okay, question number 1, it says show that the graph of y equals to f of x, figure 3 shows the graph of y equals to f of x. Draw the graph of the following f of x minus 2. F of x minus 2 is actually the f of x minus 2 is basically the graph has to go 2 units down. Okay, that means a translation of 0 to negative 2. The graph will go 2 units down. So I am just shifting the graph 2 units down overall. The resulting graph is going to be this one. Okay, this is the A part, first part done. In the second part, you are supposed to translate it by 3 units onto the right. Okay, so 3 units onto the right, meaning every single point is going to go 3 units onto the right. These are the 3 resulting points. This is the second graph. Okay, moving on to question number 2. This is a quadratic curve given, and it says figure 1.1 shows a sketch of the curve with equation y equals to x minus 4 square minus 3. Write down the equation of the line of symmetry of the curve and the coordinates of the minimum point. Okay, equation of the, if you look at the point of the turning point of the curve here, the turning point is 4 comma negative 3. That means this point is 4 comma negative 3. So the line of symmetry is going to be this line, which is x equals to 4. So in the first part, they are asking for the line equation of the line of symmetry and the coordinates of the minimum point. Okay, line of symmetry is x equals to 4, and the minimum point is 4 comma negative 3. Second, find the coordinates of the point of intersection of the curve with the x-axis and the y-axis using surds where necessary. Okay, you have to find out the point of intersection of the curve with the x and the y-axis. Okay, for y-intercept, we always make x equals to 0. Make x equals to 0 in the equation. Okay, if I make x equals to 0 in the equation, it will be this is the equation of the curve. Okay, if I make x equals to 0 into this, the equation is going to become 16 minus 4, which is 12. That means 0 comma 12 is the y-intercept. Okay, for the x-intercept, okay, 16 minus 3, it's 3 here. Okay, 16 minus 3, which is a 13. So 0 comma 13 is the y-intercept. For x-intercept, you have to make y equals to 0 in the equation. Okay, so if I make y equals to 0, it will be 0 equals to x minus 4 the whole square minus 3. 3 goes here. Square root of both sides, square root of 3 equals to x minus 4 with a plus minus here. One answer is going to be plus root 3 plus 4, and the other answer is going to be minus root 3 minus 4. These are the two x-intercepts. So the x-intercepts in terms of coordinates will be root 3 plus 4 comma 0, and then the second one is going to be negative root 3 minus 4, plus 4 comma 0. These are the two x-intercepts. Okay, then they are saying in the next part of the question, the curve is translated by 2 comma 0. Show that the equation of the translated curve may be written as this. Okay, if the whole curve is translated by, I am doing the third part here, it's translated by 2 0. That means in place of x minus 4, I have to subtract 2 unit onto the right, meaning negative 2 here. So x minus 4 minus 2 the whole square minus 3. This will become x minus 6 the whole square minus 3, which is x square minus 12x plus 36 minus 3. X square minus 12x plus 33 is the resulting equation, which they have already given us. Okay, fine. Okay, the last part, show that the line 8 minus 2x meets the curve at just one point and find the coordinates of this point. For this part, what we are going to do, if you want to show that the line and the curve are meeting at only one point, you can just simply do b square minus 4ac equals to 0. The value of b square minus 4ac will be 0. Acha, if the equation of the curve is x square minus 12x plus 33 and the equation of the line is 8 minus 2x. Okay, if I simultaneously solve them, x square minus 12x plus 33 equals to 8 minus 2x. All the terms on one side, x square minus 12x plus 2x is going to be a minus 10x plus 33 minus 8 is 25 equals to 0. So, if I take a as, I can break them, I can actually factorize it very quickly with breaking the middle term or just simple factorization. That means it is going to give me x minus 5 the whole square. So, x equals to 5. We are getting just one value of x, that means the curve is going to meet the line at only one point. Coordinates of this point is going to be 5 comma the value of y. Okay, so if I want to take out the value of y, 8 minus 2x, y equals to 8 minus 2 into 5, so it's going to be 8 minus 10, which is a negative 2. So the point is 5 comma negative 2. This is the point of intersection. Okay, moving on to question number 3. Okay, it says show the graph of y equals to g, figure 7 shows the graph of y equals to g of x. Draw the graph of the following: g of x plus 3, that means you have to shift the graph 3 units upwards. Okay, no translation on the horizontal side, but vertically you have to shift it 2 units up. So I'm just shifting it the whole curve 3 units up. The curve is going to be, the resulting curve is going to be this one which I have drawn here. Okay, for the next part you have to shift it to the right by 2 units. Okay, whenever it's a positive in this, that means on the right, and if it is a negative, that means, sorry, whenever it's a positive here, that means you have to shift on to the left, and if it's a negative here, then you have to shift on to the right. Positive 2 meaning you have to shift by 2 units onto the left. Okay, so the resulting graph is going to be, the whole graph shifts 2 units onto the left. This is going to be the graph of g of x plus 2. Okay. Then question number 4. It says the point 5 comma 4 is on the curve y equals to f of x. State the coordinates of the image of P when the graph of y equals to fx is transformed to the graph of y equals to f of x minus 5. That means negative 5 meaning the graph is going to shift, the whole graph is going to shift 5 units onto the right. Okay, so this point which is 5 comma 4, if you imagine this is the point 5 comma 4 and you have to shift it 5 units onto the right, it will become 10 comma 4. Okay, so the answer is going to be 10 comma 4 for the first part, and in this part the point has to shift 7 unit upwards. Okay, so the x coordinate will remain the same. In the y coordinate you have to add 7, so it will become 5 comma 11. Okay, moving on to the next question, which says describe fully the transformation which maps the curve y equals to x square onto the curve y equals to x plus 4 the whole square. Okay, in the first part if you are noticing, in place of x they have added a plus 4, that means it is actually being translated by negative 4 comma 0. It is going to shift 4 units onto the right, the whole graph. So it's a translation. In the first part you can write it's a translation by negative 4 comma 0, and in this part the whole graph has gone 4 units down, that means it's a translation by 0 comma negative 4. Okay, so in the second parts you just have to sketch it, So if I am just sketching it here roughly, if these are the coordinate axes and this is the graph of y equals to x square minus 4, meaning the whole graph will go 4 units down. So now the resulting graph is going to be this one. It is going to intersect at -4. Okay. This is the graph of y equals to x square minus 4. Moving on to question number 6. A curve has the equation, find the x coordinate of the point on the curve where y equals to 21. Okay, where y equals to 21, that means for this part you will have to say 21 equals to x square minus 4, 21 x square equals to 25 and x equals to plus minus 5. Okay, so the x coordinates will be plus and minus 5. Then in the second part they are saying the curve y equals to x square minus 4 is translated by 2 0, horizontally by 2 units and vertically by 0. So simply in place of x you have to write negative x minus 2 the whole square minus 4. This will be the equation. If you want you can even open it or you can just leave it like this. Okay, moving on to question number 7, where it says figure 2 shows graph A and B. State the transformation which maps graph A onto graph B. If you notice, graph A is simply translated by point 1 from here to here, that means 2 units onto the right. The graph has shifted 2 units onto the right. Okay, so you can say it's a translation of by the vector 2 0, okay, 2 units onto the right. Okay, then they are saying the equation of graph A is y equals to f of x. Which one of the following is the equation of graph of B? 2 units onto the right, meaning in place of x you just have to write x minus 2. So the resulting graph is going to be this one. Okay, moving on to question number 8. You are given that f of x equals to x plus 3 into x minus 2 into x minus 5. Sketch the curve y equals to f of x. Okay, if you want to sketch this curve, simply what you should do is on the graph you mark the 3 points of intersection with the x axis. Okay, if I make each bracket equals to 0, the 3 points which I am going to get is -3, +2 and +5. These are the 3 points. Okay, so I am just marking them here, -3, +2 and +5. Okay, and if you multiply the 3, x cube will be positive. Whenever x cube is positive, it's an n followed by u. Okay, so we know that the curve is going to have somewhat this shape. Okay, but I want to find out the y-intercept. I want to check where is the graph going to touch on the y-axis. For that I have to make x equals to 0. If I make x equals to 0 in the 3 brackets, I will be left with 0 plus 3, 0 minus 2 and 0 minus 5. That means when I multiply the constants, 3 into 2 is 6, 6 into 5 is 30. That means it's going to touch the y-axis at 30. Okay. So I just have to roughly sketch the graph showing the intercepts. So it's going to be somewhat like this. Okay, this part I haven't drawn it properly. Somewhat like this. Okay, then it says that show that f of x may be written as this. Okay, you just simply multiply the 3 brackets and definitely you will get the same. Okay, so simply you have to multiply the first 2 brackets and then whatever is the result multiplied by x minus 5 and you will get the answer to it. Okay, the last part, describe fully the transformation which maps the graph of y equals to f of x onto the graph of y equals to g of x, where g of x is this. Okay, if you're multiplying the 3 brackets and you're getting this, compare it with this, it's exactly the same. The only difference is that it was 30 here and now it's a 6 here. That means if you subtract 36 from it, 30 minus 36, you will get a -6 here. That means the graph of g of x is actually the whole graph of f of x 30 minus 36 here. That means if you subtract -36 from it, the resulting equation will be this. Okay, so you have to describe it in this case. Describe fully the transformation which maps. So you will say it's a translation by the vector 0, negative 36. Okay, question number 9, sketch the graph of y equals to 3 root x. Okay, to sketch this graph, I am just taking this graph paper. Okay, y equals to 3 root x. I am going to make the table, okay, just to have an idea as to what will be the shape of the graph. Okay, so if I take x as 0, 1, I am going to take square numbers 4, 9, 16. Okay, so if I take if I plug it in this equation, 3 into square root of 0 is 0 only, 3 into square root of 1 is 3, so 3 into square root of 4 is going to be 6, 3 into square root of 9 is going to be 9. So the shape I just want to find out 0 comma 0, or since they've asked us to sketch it, we don't need to use the graph paper. Okay, so I'm just erasing that, and I'm just okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, 0 comma 0, and then it's going to be 1 comma 3, then it's going to be a 4 comma 6, and then it's going to be a 9 comma 9. So this is the shape of the curve. Okay, this is a sketch. The graph of y equals to 3 root x is stretched by a factor of 2 parallel to the y-axis. Parallel to the y-axis, that means it's a vertical stretch. State the equation of the transform graph. The equation of the transform graph is, you have to multiply this equation by 2 outside. 2 into 3 root x is going to become 6 root x. Describe the single geometrical transformation which maps or which transforms the graph of y equals to 3 root x to the graph of y equals to 3 root x minus 10. In place of x, they have written x minus 10. That means it's purely a translation by the vector k0. Okay. Question number 10. It says the diagram shows the graph of y equals to f of x from negative 10 till 1. Outside this interval, f of x is 0. Sketch the graph of y. Sketch on the separate diagram the graph of y equals to f of x plus 1. In this case, x plus 1 meaning the graph has to shift 1 unit onto the left. So you just have to 1 unit onto the left. Okay, it's going to be this one. This is the first one, and the second one is going to be negative 3 times f of x. Okay, I don't have space here. What you can actually do is, either you first give it a vertical stretch of 3, stretch of scale factor 3, and then reflect it in the x-axis. Or you can first reflect it in the x-axis and then give it a stretch, that is your choice. So if I reflect it in the x-axis, it's going to be somewhat like this. You have to take the original graph. Okay, so reflection in the x-axis will be somewhat like this. Okay, and then giving it a stretch, that means any point which lies on the x-axis will remain the same, but the point on the y-axis, apart from any point on the x-axis, every point will be multiplied by, the y coordinate will be multiplied by 3. So it will be somewhat like this. This will be the graph. Okay. Sketch on the curve y equals to x cube. So I am doing the 11th question here. I am just sketching it. Y equals to x cube is the graph which looks somewhat like this, and n followed by u passing through the origin. Then it says, describe a transformation which maps that transforms the graph of y equals to x cube to the graph of y equals to negative x cube. Okay, it's going to be reflection in the x-axis. and it says the graph of y equals to x cube is transformed by p units parallel to the x axis, translated by p units. So, the equation of the curve will be x minus p, in the bracket only you have to write negative p. Okay. This will be the resulting equation. Okay, here we come on to the end of this question, end of this video, and then the rest of the questions from this PDF we will be doing in the next class. Thanks a lot for watching the video.